Imagine a future, right, where the fuel for ships, the basic stuff for chemicals, it doesn't come from oil wells. Instead, it's made using sunshine and CO2 from the air. Sounds a bit out there, maybe. But today, we're really getting into it, doing a deep dive on a specific piece of research. Analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping. This study basically asks, should Europe make its own green e-methanol, or is it better to import it from, sunnier places?
Exactly. And that's such a critical question right now as we're trying to move away from fossil fuels. We really need to understand the actual costs, the logistics of these greener options like
Yeah.
green e-methanol. And this study gives us a really detailed comparison of the supply chain costs.
Yeah, and methanol isn't some obscure chemical. It's already huge, used in loads of industries and increasingly as fuel, especially for ships. The study points out global demand back in 2022 was, get this, 592 terawatt hours, just massive scale. And most of that currently comes from traditional production, places like Saudi Arabia, the US, with China using a lot of it.
That's right. And the crucial point is almost all that current production, it uses fossil fuels, natural gas, coal. Green e-methanol is the clean alternative. Use renewable electricity, make hydrogen, combine it with captured CO2. It's potentially a massive step for cutting emissions.
And looking forward, the numbers are just staggering. This study mentions projections like demand could explode by 2050. We're talking 12,000 to 15,000 terawatt hours a year, driven by green shipping, the chemical industry decarbonizing.
Absolutely. So the core question this research tackles is, how do we meet that huge future demand sustainably, but also, affordably?
Which brings us right to the heart of analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping. It directly compares making it in Europe versus importing it. They focused on Germany, Finland, and Spain, right, as examples for Europe.
Yes, those three. And compare them against regions with just fantastic solar resources, specifically Morocco and Chile.
Okay, let's get to the numbers. Where is it cheapest to make this stuff, according to the study?
Well, no huge surprise here. The sunniest places win out on production cost.
Oh.
The Atacama Desert in Chile really stands out, just world-class sunshine there. By 2030, the analysis suggests costs could be like 97 to 151 euros per megawatt hour.
Wow, okay.
And then look further out, 2050. They project those costs could drop way down, maybe 50 to 95 euros. So making it in Chile could end up being significantly cheaper than doing it in, well, many parts of Europe.
That is a big difference. What about Morocco and Spain? They're pretty sunny, too.
They are, yeah. And they also show competitive costs in this study. For 2030, Morocco's range is estimated at about 104 to 192 euros per megawatt hour. Spain, pretty similar, 110 to 192. And by 2050, those drop too. Morocco looking 53 to 109, Spain 56 to 109 euros. Still good, but Chile seems to have a slight edge.
Right, makes sense. More sun, cheaper green fuel. But what about Germany and Finland in this study? How do they stack up?
Right, so as you'd probably guess, Germany and especially Finland face higher production costs. Germany's renewable mix, less ideal sun and wind, means higher costs. The projections are 127 to 186 euros in 2030, dropping to maybe 70 to 120 by 2050, depends on the scenario, of course.
And Finland? Further north?
Yeah, Finland sees even higher estimates because of its location and resources.
Yeah.
We're talking 151 to 222 euros in 2030, maybe down to 87 to 150 by 2050.
Those are really quite different cost levels across these places. What's the main thing driving those differences, according to this analysis?
Analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping really points to the weighted average cost of capital in the WACC. Basically, how much it costs to finance the project, if borrowing money is expensive or investors see more risk.
That cost gets baked into the final price.
Exactly. So places with better investment climates, lower risk perception, they'll have a lower WACC, and that helps bring down the production cost.
Okay, so it's not just about the weather. Finance matters a lot too. Makes sense. But, okay, making it cheap is one step. How do you get it from, say, Chile or Morocco to Germany or Finland? This study looked at transport too, right? Pipelines and ships.
It did, yes. And this is actually a pretty novel part of analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping. They compared pipelines, specifically from Morocco, versus sea shipping, like from Chile, looking at delivery to Germany, Finland, and Spain.
Pipelines for methanol. You don't hear that every day. So what did they find on the transport costs?
Well, this is quite interesting. For Germany and Finland, the study suggests pumping it from Morocco would actually be more expensive than shipping it all the way from Chile.
Really? Even though Chile's much further away.
Yeah, In 2030, the pipeline costs were estimated around 10 to 27 euros per megawatt hour, shipping costs. Lower, between 8 and 14 euros, and that holds true for 2050 as well. Pipeline at 6 to 19 euros, shipping down to maybe 4 to 7 euros. It really shows how efficient long-distance shipping can be.
So for those longer routes into Northern Europe, shipping wins out in this study. But Spain's closer to Morocco. How does it look there?
For Spain, it's a bit different, as the study details. In 2030, the pipeline from Morocco is projected cheaper, about 5 to 9 euros per megawatt hour versus 8 to 12 for shipping from Chile. But by 2050, that advantage narrows quite a bit. Pipeline costs maybe 3 to 6 euros, shipping 4 to 7 euros, so they get much closer.
Interesting. So distance matters, but maybe not quite how you'd first assume.
Exactly. Analysis of green e-methanol supply costs, domestic production in Europe versus imports via pipeline and sea shipping, basically concludes that shipping tends to be cheaper for distances over, say, about 475 kilometers. Pipelines have huge upfront costs, and those costs really scale up with distance. Shipping costs don't increase quite so sharply over long hauls.
Okay, so we've got the production costs, we've got the transport costs laid out by this study. Let's put them together. What's the final verdict? Imported e-methanol versus making it locally in Germany, Finland, Spain.
Right, the overall competitiveness. For Germany, this study suggests imports start to look cost competitive around 2040. By 2050, they estimate savings of maybe 4 to 14% for imports from Morocco, and a more significant 15 to 22% for imports shipped from Chile compared to making it in Germany.
Okay, that could definitely influence German strategy. What about Finland? We saw their domestic costs were higher in this study.
Finland sees potentially even bigger benefits from imports, according to this research.
Here.
Analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping shows pretty significant cost advantages across all the years they looked at. In 2030, imports from Morocco could be 6–14% cheaper, and from Chile, a pretty striking 22–26% cheaper than finished production.
Wow.
And by 2050, those savings could grow even more, maybe 19 up to 37%. So for Finland, imports look like a really attractive economic path based on these numbers.
So for countries maybe with less ideal renewable resources, like Finland, imports seem like a very strong contender economically based on this analysis. How about Spain, with its own good sunshine?
Yet for Spain, the benefit of importing is more modest, as the study points out. Because Spain does have good solar resources, the cost gap isn't as big. But the study still finds potential savings from Chilean imports, especially in the 2030s, maybe around 5 to 15%. And interestingly, for Spain, importing from Morocco by ship looked better than by pipeline in their analysis.
Okay, so it's definitely a nuanced picture. Depends on the country, the import source, the transport method. This study really breaks that down. Now, analysis of green e-methanol supply costs, domestic production in Europe versus imports via pipeline and sea shipping, also looked at payback times, right? How quickly do these big infrastructure investments pay off?
Yes, they analyzed the payback periods for both pipelines and ships. For the pipeline from Morocco, the payback times varied quite a bit. Could be a few years, could be over a decade, maybe even longer for Spain if the cost savings weren't huge in certain scenarios.
And shipping from Chile, how did that look in terms of payback?
That looked much better, according to this analysis. Shipping from Chile generally showed really attractive payback periods for all 3 European countries. Germany and Finland, often looking at 1 to 3 years payback in the 2030 scenarios, even faster by 2050. Spain also saw a pretty quick payback for shipping, especially under the higher cost assumptions in the study.
So economically speaking, shipping e-methanol from those really sunny spots looks quite promising for Europe based on this research. How does this fit with what other people are saying about e-methanol costs? Is this study aligned with other research?
Well, the study itself mentions that green e-methanol maybe hasn't been studied quite as much as, say, e-hydrogen yet, although research is growing. Right now, of course, green e-methanol is much pricier than the conventional fossil-based stuff. But the cost reduction potential shown in analysis of green e-methanol supply costs, domestic production in Europe versus imports via pipeline and sea shipping, especially for places like Chile. That does seem to align with broader expectations. That e-methanol can become competitive, especially as renewable electricity and carbon capture costs keep falling.
Right. And what about bigger picture stuff? Does the study touch on things like, I don't know, energy security?
It does briefly mention the geopolitical side. Obviously, relying heavily on imports from just 1 or 2 places carries risks, so diversifying sources or balancing with domestic production, those are factors for energy security. The study also brings up the idea of a methanol economy. suggesting green e-methanol could be really important in the whole Power-to-X landscape. It's easier to handle and store than hydrogen. It's versatile.
Like you can use it directly as fuel or as a building block for other chemicals.
Exactly. China already has a kind of methanol economy, though it's based on coal currently. But the potential for green e-methanol, especially in the chemical industry going forward, is huge.
Okay, lots to unpack there. One last quick point from analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping, transporting the ingredients. If you don't have your cheap electricity, your hydrogen production, and your CO2 source all in the same spot, what's cheapest to move?
Their analysis suggests that if things aren't co-located, it's generally most cost-effective to transport the captured CO2 to the place where you have that cheap renewable electricity for making the hydrogen.
Got it. Okay, so let's try and sum up this deep dive into analysis of green e-methanol supply costs. Domestic production in Europe versus imports via pipeline and sea shipping. It really seems to build a strong economic case for Europe to seriously consider importing green e-methanol, right? Especially shipping it from super sunny regions like Chile. Seems like it could be a cost-effective way to decarbonize, particularly for places like Finland without top-tier domestic renewables.
That's a key takeaway. And while, yes, making it at home has benefits jobs, maybe more security, the pure economics highlighted in analysis of green e-methanol supply costs, domestic production in Europe versus imports via pipeline and sea shipping, well, they're pretty compelling. Hard to ignore those potential savings.
So it leaves us with a big question, doesn't it? As we move towards cleaner energy, what's the right mix for Europe? How do you balance these economic arguments for trading green fuels globally against, the strategic desire for local production and energy independence? It's complicated, but this study, analysis of green e-methanol supply costs, domestic production in Europe versus imports via pipeline and sea shipping, definitely gives us a lot of valuable data and perspectives to chew on. And if you really want to get into the nitty-gritty, the numbers, the assumptions, we definitely recommend checking out the full study. Analysis of green e-methanol supply costs, domestic production in Europe versus imports via pipeline and sea shipping.